Hello everyone again. So this is going to be the second and the very delayed video in the upgrading your NEJE Laser Engraver, aka the Hicktop Laser Engraver, aka the ELU Laser Engraver, and 1,001 other names. A long time ago, about a year, I did a video and I posted the details about how you actually take one of these laser engravers and you then upgrade it to full GRBL compatibility by replacing this little board here. I'll try to avoid that reflection in the future. And so I got a lot of questions about details with the wiring, details with installation, things like that. So I decided to put up a second video that actually covers these specifically. And also there were concerns in the last video where people could not hear me well. And so for this video, I'm actually using a proper headset versus a standalone microphone. And I have a wonderful link in the best copycat Big Clive style, so that if anybody sees this video, they don't know where to go, that's where you can go to get this video and all the information. And so, let us start out with one of the first things. If you haven't seen the video where we performed the major upgrade before, I would advise you to go through and find that, and it is linked from this video in the video description. And it will give you all the basics about what this board does, how it works, how you install it, and how you hook it up. And so in this video, we're going to cover the nitty-gritty about how the signals and how all the electrical stuff is connected. So in the last video, some of you may remember that one of the things I did to provide the power, because although the stock part needs just USB 5-volt power, with this new GRBL CNC shield, it needs 12-volt power to power the motors and still 5-volt power to power the laser. And so what I opted for is to use a power supply like this. And what it has a standard 3-pin power supply connector on one side, but then on the other side it has one of these connectors that you're used to seeing on a PC power supply. So this is like a very small PC power supply. And this is important because, let's see if we can get some autofocus action happening. Oh, we've got some terrible reflections. There we go. Okay. Anyway, the short is that this particular power supply, of course, because it's a PC power supply, gives us 12 volt and 5 volt. It gives us 12 volt at 2 amps to power the motors and 5 volt at 2 amps to power that laser. And lasers do need quite a bit of juice, especially this one, which is the 1000 milliwatt laser. And so what I did to do this was there's this big hacky ugly wiring harness that actually gets the power where it needs to go. And we are going to now walk through exactly how this wiring harness is connected. Let me get my screwdrivers out and we will take it apart and then we will go through this. Doo-dee-doo. Should put some weight music in here or something. Okay. Put that piece out of the way. We won't need to talk about that just yet. So, this is the wiring harness that I made. And you can see it's actually got a PC power supply plug on one end, and then a bunch of solder connections, and it branches off the power in various ways. Sorry, I'll try to keep the video on frame here. And in the PC Power Molex, they call this a Molex, standard, in this case, let me check my notes so I don't say anything wrong. So, the yellow wire over here is actually going to be 12 volts. The red wire over here is going to be 5 volts, and the two black wires in the middle are both going to be ground. And so you can use either for ground or connect them both together. They're connected internally in the power supply. So the blacks are ground, 5 volt is red, 12 volt is yellow. And then as you can see actually on the other end, I have in fact soldered together both of the grounds together here and then had a branch off. I suppose I didn't need to branch off this way. Anyway, did a branch, so that I can connect the grounds to two different places here. Actually, I did have to solder these together because there's an interesting detail with this and a lot of these power supplies. It's going to be difficult to see, get the focus. You can see on this connector here that there are metal contacts on all of these round holes except for the one right there. This is a fairly standard thing with these power supplies. They only have ground on one of these pins, and I wanted ground to be on both of those pins, and the reason why will come up later. And so that's why in that connector down here, I have soldered them together so that on this side, ground is available on both of these pins internally versus simply only being available on one. Now this is a really messy wiring connector, so I won't try to use that to walk it through, but I do have some visual aids that will help us go through and explain all of this. So, again, in my best copycat Big Clive style, here is the diagram of the wiring connector. So right here, this represents the PC power supply Molex, which is going to be this connector right there, or alternately, that connector right there. They amount to the same thing. We have the pins here, and then we have yellow, which is 12 volt. We have the two blacks, which go to ground. If you're unfamiliar with the electrical notation, this is the symbol generally considered to be ground or 0 volts when you're dealing with electricity. And then this is red, which is 5 volts, which is going to be power to the laser. So this is just a better graphical representation of what I've soldered here. And we will have these pictures up on the web URL on GitHub not soon after this video goes up. And so, now that we have all the power we need coming from that power supply brick, we have to then get it to the, first of all, to the actual shield on the Arduino that's powering our laser engraver. And so where that will go is hard to see, and I don't dare move the camera, so maybe I put this up so we can get some nice autofocus. Ooh, and I just bumped the camera. That's always bad. All right. One day I'll get a real camera. Come on. Anyway, although it's difficult to see, I do have some better photographs that I will put up statically. This connector, this blue one with its screw terminals, this is where the power connects in from that harness. This is the 12 volt connector, and it's very hard to see. Ah, there's a good picture. Oh, it was a good picture. Autofocus is the bane. Anyway, what this says is that it actually says 12-36 volts, which means that the input power to this can be anywhere from 12 to 36 volts. And so we have 12 volts, and most things will probably use 12 volts, then that is perfect for us. And so how this will hook up is that connector, which is represented by this block right here, will take the 12 volt power, which is, let me remember my colors so I don't get in trouble, which is yellow. This yellow wire, 12 volt connector, goes into the connector on that terminal block that's labeled with a positive symbol, the plus symbol. And then one of these ground wires then goes into the one labeled ground. So let's actually do that right now so we can all follow along. Now, so the 12 volt is actually, let's put it over so it's sort of in the middle. I might use Zoom one day, probably not. Okay, and my big fat hands are in the way there. See if we can find a way so you can actually see, because watching me screw in screws is always enjoyable. Okay, so that is the positive wire going into the one labeled positive, which is on the right side when you're looking at it. And then one of these wires, which are the ground wires because they're soldered to the black. And one of these wires, I'm going to use that one, goes into the other side, which is the 0 volts ground, whatever you want to call that. Get that nice and tightened down, and good. So that means now, with this power supply, with these two Molexes connected, it will deliver 12 volts to this control board. And one of the other questions going off of that is how the stepper motors were connected. Now this is one again where I guess having Zoom would have helped, but I do have some visual aids, and it's not that complicated when you look at it. So the stepper motor connectors are, at least the way that I've done it, you can actually do them in particular order you want. On my motors, the wires are white, yellow, black, and red, and I have connected them so that the white is at the top of this connector and then going downward. If you connect them backwards, as in this case red at the top, it means that the motion will be reversed, but it won't actually damage anything, so that's an easy fix. If you happen to connect them backwards, things will just run backwards. And in order to connect them, between each of these red circuit boards up here, they call them drivers, there's actually a 4-pin connector. It's very difficult to see, but I do have a higher quality photo. And it's a standard 4-pin connector. And on these little connectors, you can actually see there's 4 holes, and they are the same spacing and they're the same size. So you have to just line it up so that the pins on the board go in those holes on the connector, and just push it down flush so that all 4 wires have made connection, and that's it. And so this one is for the X connector, and X in this case means the going back and forth this way. And the other one going down here is the Y connector, which is the moving forward and backward. And once you have those connected, then these motors will run. And in the last video I did, we also covered how to change and adjust the voltage and things like that, so I won't bore you with doing that again. So now that we have the electrical wiring, the 12 volts for this connected, let's talk about the wiring for powering the laser. Now on the board that came with this laser, it had the necessary switching electronics built in to power the laser directly without any extra hardware. You simply use this this white connector you might be familiar with, which is actually a lot like a fan connector in some things, and then plugged it directly in the board, and it would handle switching on and off and things like that. Now, these boards, they can't handle doing that sort of power directly by themselves. They're just not built to do that. But it's not that hard to actually make something that will give us the ability to control the laser, switch it on and off. Previously in the video, I used a circuit that was based off of what's called a Darlington transistor, called the TIP 120 Darlington transistor. That's a mouthful. And while that works, I found out later that that is actually not a good circuit to use for this case, because the TIP 120 has something, a large something called a voltage drop, which means that when you are using it to switch power, you can lose sometimes upwards of or close to 2 volts, which if we were switching 48 volts, that losing 2 volts is not a big deal. But considering that the laser is running at 5 volts, losing 2 volts or even 1 volt or even half a volt will actually really hurt our laser performance. So the alternative to that is to use something called a MOSFET. Now this is a little board that I got off of Amazon for, I think it was less than $1. And what this is a little thing. It looks like the TIP 120 we used before, but this is actually a MOSFET. And this MOSFET is going to do the same thing that we did before with that Darlington transistor, but it's going to do it without so much voltage loss. But the principle will be the same, so that the power will come in from our big fat connector from the power supply. In this case, it will be the 5-volt red wire, and it will go to this thing, and then it will be switched on and off to this wire, which then goes to our laser just as normal. And then there's additional 2 wires here that go from these pins on this board to the pins here labeled SPNEN, which stands for spindle enable, which will actually turn the laser on and off. Now, before I go any further, I will have a link to this particular item you can buy online. However, you can solder one of these up yourself for probably the same amount of money, and it will be better because this one is based off of a MOSFET called the IRF 520. And without boring with the details, this one is made to be switched by higher voltage electronics. And that means that in order to completely switch this thing on and off, it wants to have 10 volts into it to switch whatever other power you're putting into it. Now, the problem with that is things like the Arduino and a lot of other electronics like this, they are based on something called TTL voltage, which is actually 5 volts, sometimes even less, 3.3 volts. And so that means this thing, while it will switch on 5 volts, it's not going to do it very efficiently. For this laser, only consuming the few milliamps that it is, it's all right. But if we were doing anything larger, you'd need to get a MOSFET, called an N-type MOSFET, that uses TTL switching. And there's actually a variant of this called the IRL 520, the L stands for logic, which can switch with 5 volts, although they don't make that anymore and it's very hard to find, and you're better off going and finding some other compatible MOSFETs. But short is that they will all say logic level in the description. There'll be N-type and there'll be logic level. And I will put a link to a couple that I have had some experience with that have worked. But in the meantime, if you see one of these on Amazon or eBay for really cheap, it will work for a laser that's only this one, which is 1,000 milliwatts, and it'll probably just be just fine for now until you were to solder together a much more robust thing with a proper board. Let's look at that schematic now. So this schematic is actually both how the shield switches the laser on and off, and it also covers a lot of the electronics that are in this module. So this actually is schematic is more how you could build one of these yourself using discrete electronics versus using one of these, but you could also use one of those, and I'll cover the connections. So the short of this is that you have the spindle enable pin. It goes through a resistor, and although the camera won't be able to show it, there's actually a resistor here. And I have left something important out of this schematic. Let me get my Sharpie of fixing, and we will actually get this connected here. So we are going to actually bridge that to here. Okay. This is going to be a... No, you know what? I've totally done this wrong. I have totally done this wrong. You know what? I have totally done this circuit wrong. So let's get out a better pen. When I put this up on the web, we'll have a better fixed schematic, but I have been totally doing this wrong. Instead, what is going to be, so let's assume this resistor is not here. Let's just take that out. All of that, take it out there. Let's assume this was connected all like that. I have really messed this up now when I look at it. Okay, the resistor that we care about is actually going to be here. And this is going to be a 10K ohm resistor. I really want to make sure that all of that is scribbled out. No, good. Okay. So what's important and why that's important is that MOSFETs are very sensitive to, they call it transient voltage, but basically any voltage that might happen to come across the wire at any time, they can begin to switch at very low voltages. And what can happen when your GRBL board is booting, like when you plugged it in, it can send a small voltage spike along this, which is only just a few microamps, microvolts, but it could be enough to actually switch this on momentarily, which would switch on the laser. And if you weren't wearing eye protection, it could cause eye damage, or if your hand happened to be in the way, it could burn your hand, or etc. And so this resistor here creates what's called a weak pull down to ground, so that if there's any sort of like really random transient voltage, it will be sucked into ground instead of actually going here and turning on the transistor. But when this is actually enabled properly by the Arduino, by that pin, it will be sending enough amperage and enough voltage to counteract that very weak pull down, and it will be enough to trigger this. So I've already started this video. I'm not going to back out now, so we're going to keep going with this and just assume I did that right the first time. Glad I caught it though. So assuming that you've wired it all up like this, the signal comes here, jumps over our little thing there, and it triggers this. And the short is that if this signal is greater than the signal of ground, which is here, it will switch this line and connect this over to ground. And this is something, the technique is called low side switching. It's a very easy thing to do. And the short of it is that this is like an on-off switch that can handle high voltages very quickly. So that when this thing is normally at 0 volts, when this goes up to 5 volts, as in the Arduino turns the pin on, this will be switched, and so the connection will be made between this pin and this pin, which is ground. And that's important because when we look over here, this is the 5 volt power supply from this power, and that's going into one side of our laser. Oh, and ignore this where it says 430 nanometers. Chances are, if you're watching this, your laser is 445 nanometer or 405 nanometer. This was just the thing that I found in the Fritzing parts library that was closest, so don't worry about that. The important thing is that this represents the laser diode. So the 5 volts is going in this way, and then this is connected to ground that way. So unless this MOSFET is switched on, the power cannot travel from the positive to the negative, so that the laser will not turn on. But once this pin is turned on, this connection to ground is made, and so the voltage can travel all the way through here, or the current, I should say, can travel all the way here, thus turning on the laser. And that's the short of it. And that's what this little red module does, but this is not a very complicated thing for anybody who has even the slightest understanding of a soldering iron. You could solder this yourself with absolutely no trouble. To do this, all you would need is one 10,000 ohm resistor, which is totally easy to find anywhere, and an N-type MOSFET, which is equally easy to find. You might find one of these for, depending on how many you buy, between 50 cents if you buy them in bulk, or maybe as much as $2, but they're not that expensive. And these resistors you could get probably dozens for $1, and you can get them anywhere online, Amazon, or any of the other places that you choose to shop, eBay, wherever. And this is the laser that you already have. In my case, I chose to actually reuse the connector for the laser here, and then so I could use these screw terminals, but there's nothing stopping you from actually just clipping these wires off and connecting them directly here to these screw terminals if you choose to use one of these modules, or directly soldering it to the MOSFET if you want to do that instead. And finally, the last not finally, let's actually walk through. I'll say finally in a moment. We'll stick to form and we'll actually show the connection of this. So this is our board here, and it's hard to tell up top. I do have better pictures, but there's a side here. It says VIN, which stands for voltage in, and GND, which means ground. And this means the input power. And so it wants the ground connector from this to be plugged in right there. So we will plug that in and tighten up our screw terminal. Make sure it's really tight. It could be tighter. Let's get a better screwdriver for doing those. Oh, okay, good. Now that one is tight. And the second one is labeled VIN, voltage in, and that is going to be the red wire, which is our 5 volt input. And that goes in the other terminal. And we then carefully, because I needed 3 hands here, tighten that down. Now, these 2 wires on the other side, on this other blue connector, labeled V positive, V plus on that side, V negative, V minus on that side, and going with the international color code, V plus is red in that case, and V negative is black, and they actually go through this connector and actually stick to the colors, but if you were to solder it directly, you wouldn't need to worry about that. But the short is that red where it says V plus, black where it says V minus. And finally, there's this little connector here at the bottom, and there are 3 positions. One is labeled SIG, stands for signal, and that is going to come from the spindle enable, SPNEN pin of the shield. And then the other one is simply labeled ground, and that could connect up to any ground anywhere because your grounds will all be connected together. But conveniently, when you look at the spindle enable block here, you can see that one side of this pin block is labeled white. That's actually where the signal goes. And one side, the other side is labeled black, and these are all ground. So in this case, I have the connector. So white is signal going to that side, black is connecting to ground. and that connects up with this wire there. And finally on this board, there's a pin labeled VCC. Now, usually VCC does something and is important. In this board, that is actually not connected to anything. And so you just ignore that completely. It doesn't do anything. It's not soldered to anything. Just ignore it. So you only use the outside SIG signal pin and the ground pin, and that's all you need to do. Now I can finally get to the finally thing. One of the other things I have added to my laser engraver, and something that makes it really good to use a PC-style power supply, is adding a fan. And in that case, I'm using a big computer fan like this. This is actually I think it's a 120 millimeter computer fan I just had lying around from one of my old computers. And it has a connector on the end, just like one of these, so I can actually plug it in thusly. I said thusly. Plug it in thusly. Ah, there we go. All right. And so that means when 12 volts is applied, this fan will turn on. And I then just actually stick the fan, usually, that's actually the wrong way around. The airflow goes, oh, that was the right way. Okay. The airflow goes this way. And I usually stick it on the top like that. Don't even attach it. And this does two things. It blows away any smoke that is generated from the laser burning. But also, crucially, it cools off the laser because of this big black thing is a heat sink. And while that might help dissipate some of the heat, if you're running this for a long time, it might not be enough to actually dissipate the heat enough. And so simply having air blowing on this will help dissipate a lot of the heat. Final thing it can do is it can cool down the stepper motors. The stepper motors, it's this thing right here, which moves the laser back and forth, and then there's another one buried down here at the bottom, which moves it back and forth, forward and back, I should say. And it will cool them down because it's blowing air down here. I'm less concerned with that because in practice, if you've tuned this little potentiometer here properly, even with constant motion, these motors just never seem to heat up. So I actually don't worry about that much at all in this case. Just they can get cooled by this fan if they want to, but it's really not that important if they're there. It's really to blow the smoke away and then to cool the laser diode here. So I hope that has cleared up some confusion or some questions with some of you who have been wondering about the details about how this is wired up. I know there are a lot of ways you could actually clean up this wiring. It is actually a bit of a mess, and that's just the way I do my wiring. That's the way I like it. However, you could make the wires shorter, route them properly, do whichever. It's all the same. And what else am I going to cover? Well, one of the things I do want to cover very soon is another upgrade to this laser engraver, which is, suppose you don't like this laser, either it's not powerful enough or it's the wrong kind of laser. I'm going to cover upgrading this laser because I have, over here, I have this thing, and this is a 500 milliwatt laser, which is actually half of the rated power of this laser. However, crucially, this is an 808 nanometer laser, whereas this laser is I believe a 445 nanometer laser. So this laser is it burns things differently, basically. Certain materials are more susceptible to being burned by certain wavelengths of laser, certain colors of laser, so this burns differently depending on the material. This one is a fun one because it is technically in the, I believe it's in the infrared range, so you can't actually see this with your naked eye. It's good and bad because it's neat because you have an invisible laser, but it's also bad because if you accidentally turn this on and you can't see it, you could cause yourself severe eye damage and not know it because your eyes cannot see infrared light like that. So that's a fun one to deal with, and we'll deal with it later. And also this one is interesting because it runs directly on 12 volt power, not 5 volt power, and it has a built-in wire here for switching the laser on and off, which takes the place of that red board. And so that's all neat and dandy, so you don't have to mess around with that. Now, of course, the obvious thing is this is a different size. So what do you do to actually attach this thing there and make it work? Well, I actually have solutions for that. And the next video, I will cover that. So I guess we'll call this a teaser. And thank you for watching this video. And please, if you have any questions, feel free to leave them in the comments. And I will answer as many questions as I can. Thank you for watching, and I will talk to you later.